and welcome. Today, we're going to explore a really big idea, one that's shaping the entire future of artificial intelligence. And it's a story that's less about a sudden revolution and much more about a fascinating evolution. Okay, so this is the question that seems to be on everyone's mind, right? Large language models, or LLMs, have just completely taken over the conversation. They're so powerful, so seemingly magical, that it's really easy to think that they're just making everything that came before them obsolete. But is that actually what's happened? Well, to get to the real answer, we have to look under the hood. We've got to see what these LLMs are actually built on. And you might be surprised to find out that it's the very field they're supposedly leaving in the dust. So here's the core idea for today. It's not about LLMs replacing traditional machine learning. It's much deeper than that. It's about a relationship of co-evolution. It's a symbiosis. They need each other to survive and to thrive. You know, LLMs didn't just appear out of thin air. They are the direct result of decades of hard work and deep learning. That powerful transformer architecture that's at the heart of every LLM, that itself is a product of dedicated foundational machine learning research. These models are literally standing on the shoulders of giants. And this quote just says it all, doesn't it? An LLM is only as good as the data it's trained on. But think about it. How do you actually curate petabytes of data from the wild west of the internet? You can't have people do it by hand. It's impossible. You need another layer of intelligence just to prepare the meal. And that layer, well, it's a really sophisticated pipeline that's powered by, you guessed it, more machine learning. Before an LLM ever sees a single byte of data, a whole team of other ML models is working behind the scenes, filtering out junk, getting rid of duplicates, and even scoring the quality of the text. So it makes one thing crystal clear. If you want to build a better LLM, you first need better ML models to find its food. So machine learning builds the foundation, but it's also absolutely crucial for making these massive, incredibly expensive models practical for anyone to actually use. So once you have this giant base model, how do you specialize it, say for medicine or for law? Trying to retrain the whole thing is just wildly expensive. But machine learning research has given us these brilliant methods like parameter-efficient fine-tuning, or PEFT. Instead of messing with billions of parameters, you just freeze the original model and train a tiny fraction of new ones. It's kind of like teaching an expert a new skill without making them go back to school for 4 years. And the impact here is just staggering. Using a technique called QLoRa, you can fine-tune a massive 65 billion parameter model on a single GPU in about a day. This is a complete game changer. It democratizes access to powerful AI that used to be locked away inside just a few big tech labs. This is also how we get these huge models out of the cloud and right onto your devices. We use classic ML techniques like pruning, distillation, and quantization to shrink them down so they can run on your phone. This whole movement towards small language models, or SLMs, means faster, more private AI that works right in your pocket. No internet connection required. And that brings us to our next big idea. For all their incredible power, LLMs are not a silver bullet. You know, like the old saying goes, if all you have a hammer, everything looks like a nail. But we have more than a hammer. In the world of AI, there's a really famous idea called the no free lunch theorem. And it basically says there is no single master algorithm that's the best for every single problem. And what's funny is that the rise of LLMs has actually made this clearer than ever. It's helped us see exactly where other, more specialized models are still the undisputed kings. And this really lays it all out. Yeah, LLMs are fantastic with messy, unstructured text. But for the clean, structured data in your company's database, for things like fraud detection or forecasting sales, models like gradient-boosted decision trees still dominate. And for data that's all about relationships like a social network, graph neural networks are way better. It's always about the right tool for the right job. So what this all really points to is a huge shift in thinking, right? We're moving away from this us versus them mentality. The future is hybrid. It's about building systems where these different models work together, where an LLM might act as this amazing tool to process messy language into clean data that a more specialized model can then use to make a really solid prediction. And this whole collaborative spirit, it gives rise to something totally new, a complex operational layer, a whole ecosystem that's powered by machine learning for machine learning. Let's call it meta ML. It's this idea of using smaller, faster, cheaper ML models to manage, to secure, and to check the work of the big, expensive LLMs. And this isn't just some neat trick. It's quickly becoming the essential infrastructure we need to deploy AI safely and efficiently at a global scale. And here are some great examples. To deal with the high cost of running a giant model for every little question, we can use a small ML classifier as an intelligent router that sends the query to the best-sized model. To stop toxic output, we use specialized ML-powered guardrails that are way smarter than simple keyword lists. To fact-check an LLM's claims, we can train a tiny, dedicated classifier that's hundreds of times cheaper to run. You see the pattern? Small ML is solving big LLM problems.
And all of this, it's all building toward what might just be the most profound shift yet: the rise of truly hybrid agentic AI systems.
In this new world, the LLM stops being just a chatbot that answers your questions, it evolves. It becomes something more like the brain or the cognitive orchestrator of a much larger system. It starts intelligently directing a whole team of specialized models and tools to solve really complex, multi-step problems. So this agentic workflow lets an AI tackle a problem a lot more like a human would. The LLM gets a goal, it thinks, it makes a plan, and then it delegates. It might decide to call an API to get the latest stock price, then use a graph neural network to analyze market trends, and then store what it learned in a memory bank for later. It's not one model anymore, it's a system.
And the future of this isn't just one agent with a few tools, it's a whole society of collaborating agents. Just imagine a system where a powerful LLM acts as a project manager, delegating tasks to a whole team of specialized agents, each one built with the absolute best machine learning model for its specific job. This kind of system is just more efficient, more scalable, and ultimately far more powerful than any single model could ever hope to be.
And that right there is the ultimate takeaway. Machine learning isn't fading away, not at all. It's becoming the architectural blueprint for the entire next generation of intelligence. The central challenge for the field has shifted. It's no longer just about building a bigger model. It's about designing a smarter system. And in that future, the LLM might just be the cognitive glue that holds it all together, allowing a diverse society of specialized machine learning intelligences to collaborate and solve problems we can barely even imagine today.